Good morning everyone. Today we start with our new topic of function, that is call by value and call by reference. So there are two methods for calling a function. First one is call by value method and second one is call by reference method. These two methods are generally differentiated by the values passed to them as a parameter. On the basis of the value that are passed to these method as parameter, on the basis of these values, these methods are different. So first we recall the previous video, that is what are the actual parameter and what are the formal parameter. Then we go to our topic. So as I told you, actual parameters. So as I told you, the parameter passed to a function are called actual parameter, and whereas the parameter received by a function are called formal parameter. Here in this figure we see that here add is a name of the function and m comma n are the parameters of that function. So here m and n both are the parameter that are called. So these parameters are known as the actual parameter, and the value of m and n are copied to these parameters a and b. M value is copied to parameter a and n value is copied to parameter b. So these parameters are known as formal parameters. The value of actual parameter is passed to that function a, and the value of m and n are copies in the value of a and b. So a and b are formal parameter and m and n are actual parameter that are used in function. So now we come to the methods, that is call by value and call by reference. First one is call by value method. In this method, parameter passing method copies the value of actual parameters into formal parameter, and these two different parameters store values in different location. What is done in this method? This method we copy the value of actual parameter. What is actual parameter? Add m comma n. In the previous slide we see add m comma n. So m comma n are the actual parameter. We copies the value of m comma n in the formal parameter, that is a and b, in the different location. So this is known as the call by value method. So during this execution, whatever changes are made in the formal parameters are not reflected back in the actual parameter. Because why these changes are not reflected in the actual parameter? Because the location of these parameters are different. So if we change in the actual parameter, then that is not reflected in the formal parameters. So this is an example. Here x is equal to 10 and y is equal to 20. And there is a function fun x comma y. We printf x is equal to %d and print the value of y. So we print the value of x and y, and there in main function x value is 20 and y value is 10. Here x is given as x value is 20 and y value is 10. These value are here x is 10 and y is 20. X value is 10 and y value is 20, 10 and 20, and these value are passed in these x 10 and 20. These are copies. But here x value is equal to 20 and y value is 10. So value will change in that place and it will not reflect in here, because there are different memory location for both the formal parameter. These are the actual parameter, and these are the formal parameter. So values are different for both actual and formal parameters. So changes are not reflected because of the different memory location. So this method is known as the call by value method. So here it is an example. Here int a is equal to 10 and b is equal to 20. A is equal to 10 and b is 20. A value is 10 and B value is 20. Swap A comma B. Here we pass the values. Printf A and B value will be print. In main function, what is good? Here this is a swap function and there is a value of X and Y. Okay. So here it is swapping is done. When we call this function swap A comma B, then it is automatically go to the function. So A value is copy in X place and B value is copy in Y place. So in place of X the value is 10 and in place of Y $20 value will be written. X place 10 value is written and Y place 20 value is written. So T equal to X, here there is another variable that is T. It is empty and X value is copies in T. So X value is copies in T. So here T value will be 10 and X is equal to Y. Y values is copy in X. So in place of 10, here whatever we write value of Y, that is 20, and T value is copy in, here the swapping is done, the value of T is copy in Y. So T value, that is 10, it is copied in Y. So final, what will be the value of X and Y? So X value will be 20 and Y value will be 10, and what we write in place of A and B, that is 10 and 20. Okay. So this is how we done call by value method. I think it is clear to everyone. Now second method is call by reference. In this method, instead of copies the values of variables, we are passing the addresses of variable to other function. What we do? We don't copy the value of variable. We just pass the address of these variable to the function. In this method, both the actual and formal parameters refer to the same memory location. Here we don't use the different memory location, we use the single memory location, or we can say that we use the same memory location for the call by reference method. So it is obvious that when we use the same memory location, then the changes made in the formal parameter will also reflect in the actual parameter. So here X is equal to 10 and Y is equal to 20, and here we don't copy the values of X and Y to these. We just pass the address of these variable. We pass the address of X variable and we pass the address of Y variable to PTR1 and PTR2. Here PTR1 is equal to 20 and PTR2 is equal to 10, and we want to print the value of X and Y. So initially we have the value of X is 10 and Y is 20 and the address of X is 1000 and Y is 2000. Then the PTR and PTR2 address, we just pass the address of X and Y to this location. So PTR1, the 1000 X address is copies and PTR2 2000 address, that is Y, is copies. Now PTR1 is 20 and 10. Then PTR1 means 20. So it is also reflect in the X. So X value will be changed at 20 because at 1000 location what value we store? 20. So here the value will be changed and it will 20. Then now the Y value will also change. It will become 10. So the output will be 20 and 10. And here the change in one memory location will also reflect in another memory location, that is formal parameter value change, then the actual parameter value also change. This is known as call by reference method. So this is an example of call by reference method. Here A and B, A value is 10 and B value is 20. Now we pass the address of A and B. Suppose the address of A is 1000 and the address of B is 2000. Then when we call this function, then it will automatically call from here Then here there is a pointer variable x and y. Then we just pass the address of A and B to x and y. So 1000 is written in place of x and 2000 will be written in place of y. Then t is equal to address of x and pointer of x is equal to pointer of y. Then swapping is done and finally the answer will be x is equal to 20 and y is equal to 10 and a is equal to 20 and v is equal to 10. The values will be, the changes will be reflected. If we change the value of x and y, then it will be also reflected in a and b. So now what is the difference between the call by value and call by reference? And this difference is very important from the examination point of view. First difference is, while calling a function, we pass value of variables to it. Such functions are known as call by values. We just keep in mind, when we copy the value of actual parameter to the formal parameter, then this type of method is known as call by value, because we copy the value here. And in call by reference, instead of copying the value, we just pass the address of these variables, passing the address of these variable. We pass the address of these variable, it means location of variable, then this is known as call by reference. And when we pass the values of these variable, then it is known as call by values. Then the second difference is, the value of each variable in calling function is copied into corresponding dummy variables of the called function. And in call by reference, the address of actual variable in the calling function are copied into the dummy variables of the calling function. Then the third difference is, the changes made to the dummy variable in the called function have no effect on the values of actual variables in the calling function, means changes are not reflected. If we change the value of formal variable, then it is not reflected in the actual variable. But in call by reference, because we use the same memory location for both the variables, so the changes are reflected in call by reference. Now the fourth difference, the values, we cannot alter the values of actual variable through the function call. We cannot change the value of variable through function call. In call by reference, we can change the value of variable through function call. And the last difference is, value of variable are passes by simple technique, and here in call by reference we use a technique that is known as pointer. We use the pointer variable to pass the address or to store the address. Now after the call by reference and call by function, the next topic is recursion. Recursion is a process in which function call itself directly or indirectly. When a function call itself or repeat itself several times, then this process is known as recursion. Here a function fun, and inside that function fun is repeating itself. So this process is known as recursion, because this function is repeating itself several times. So this is known as the recursion. Types of recursion, there are 4 types of recursion. First one is direct recursion, second one is indirect recursion, third one is tail recursion, and last one is non-tail recursion. Now the definitions. Direct recursion, a function is called direct recursive if it calls the same function again. If a function calling the same function again and again, then this is known as the direct recursion, and it is also known as simply the definition of recursion, because fun in calling the same function. Then indirect recursion, here a function called indirect recursive if it calls another function and that another function directly call that function. This is known as indirect function. Here there are 2 functions, first one is fun and second one is fun2. In fun function, what is happen? Inside the fun function, there is another function that is calling fun2 function, and it is a part of fun2 function. The function fun is calling. So here fun function is called indirectly and fun2 function is also called indirectly. So this is known as indirect recursion. Now third one is tail recursion. A recursive function is tail recursive when recursive call is the last thing executed by the function. When there is a last function that is executed by that function, then this is known as tail recursive function, and there is no need to keep the record of the previous state. it is an important point in tail recursion that we don't need to keep the record of the previous state. Then last category of the recursive function is non-tail recursive function. A recursive function is non-tail recursive when recursive call is not the last thing executed by the function, and after returning back there is something left to evaluate. Means it is not the last function, but in tail recursion it is the end of a tail, so it is the last function. Now what is recursive function? A recursive function is a function that call itself, and these types of calls are known as recursive calls. Recursion involves several number of recursive call. However, it is important to impose a termination condition of recursion. We also must impose the termination condition. Recursion code is shorter than iterative code. When we use the loop code, then recursion instead of looping, recursion coding is shorter in length than looping coding. However, it is difficult to understand. Recursion cannot be applied to all the problem, but it is more useful for the task that can be defined in terms of similar subtasks. For example, recursion may be applied to sorting, searching and traversal problem. These examples are important, that we can use the recursion in sorting, searching and traversal problems. Sorting, searching and traversal problem. Iterative solutions are more efficient than recursion since function call is always overhead. Any problem that can be solved recursively can also be solved iteratively. However, some problems are best suited to solve by the recursion. For example, Tower of Hanoi problem, Fibonacci series and factorial one. These are the some important problem that is solved using the recursion. In Fibonacci series, we use the recursion to solve the problem. So, how does the recursion work? Here there is a recursive function, and in that inside this recursive function, it is also called the same function, that is this call is known as recursive call to itself, because the function call itself, and in main function we call the function recurs and it is now called that function again. So, this is how the recursion work. So, I think it is clear to everyone that what is recursion, what is call by value method, what is call by difference method. One thing kept in mind, that when we talk about the call by value, if we revise that in call by value, we use different locations, So, if we change in the actual formal parameter, then it will not change reflect in the actual parameter, and copies the value of actual parameter to formal parameter. This is one thing. And in call by difference, what we do? In call by difference, what we do? We pass the address of these value. So, for this purpose, we use the pointer variable to pass the address, and here the changes are reflected because we use the same memory locations. Okay. So, that's all for today, and thank you.